Okay, this is my second video on differentiation, and in this video we will look at finding the equation of the tangent and the normal at any point on a curve, and we'll use differentiation to do that. Before I go into it, let's talk about what tangents and normals are. So for example, if I want to know what the equation of the tangent is at this point on my curve, what we would normally do is we would normally draw a tangent at that point, something like so. Just fix this in place. So we'll draw a tangent at this point on the curve, and then we'll find the equation of that tangent. Just to give you some background information, since this is a straight line, the equation of that line will take the form of y equals to mx plus c, where m is the gradient of that line and c is where that line cuts the y-axis at that point just there. So that's the tangent of the line. So I'll label that as of that point on the curve. So I'll label that as my tangent. Okay, so now we've got that. Now, before we move on further, I must say this to you. So if you looked at my previous video, you'll remember that I said in that video that by differentiating the equation of this curve, what we're actually doing is finding the gradient at any point on that curve. So that means that if I'm needing to find the equation of the tangent, then once I differentiate the equation of this curve, I would already have my m. All I need to do is substitute that into the equation into the first derivative, which is my differentiation. Okay, and all I need to do is find the c value where it cuts the y-axis, and then I'm done. All right, that's done. So that's the tangent. The normal, you might be wondering, what is the normal? Well, the normal on this in this case is a line that's perpendicular to the tangent. So the normal would look something like that. Let me just put it in place first. So that will be the normal to that curve, and the normal is always perpendicular, like I said, so it will be 90 degrees to that. And you can also find the equation of the normal. Now the normal and the tangent, they do have a small relationship between them, and that small relationship is the fact that I'll write probably the normal equation in green. So the normal, it shares sort of the same gradient as the tangent, but the gradient is slightly altered. The gradient of the normal, I'll put it down here, is minus 1 over m. So whatever the gradient is for the tangent, just reciprocate it and change the sign, and you will get the equation of the normal. Okay, so I will just write that in here as minus 1 over mx plus c, and obviously again c would be where the equation, where the normal cuts the y-axis again. So that's lots of information to take in straight off the bat. But yeah, so the tangent, it just touches the curve, and the normal is perpendicular to the tangent. So when you see tangent or normal, you know what that means. And if you know what your tangent is and you found the gradient, just reciprocate it and change the sign to get the gradient of the normal. All right, let's look at some examples. So here are some examples we will be looking at in a minute. You might want to pause the video and jot them down. But what we're going to do is we're going to calculate the equation of the tangent and the normal at any given point. Okay, well, and then we're going to, at the point given here. So I've given that point there, so we're going to calculate the gradient of the equation of the tangent and the normal at that point. Okay, so here we go. Here we have a function. It's a quadratic function, And if we were to plot this, we'd get, I'll probably just do a quick aside over here. If we were to plot this, we'd get a curve that probably looks something like that. And we're trying to find out what's the gradient at some point P. This was probably ill thought out, where we got 2 and 3. So we want the equation of the tangent and the normal at that point. Okay, well, let's go for it. The first thing, before I'm able to find the equation of the line, I need the gradient. And to find the gradient, I need to differentiate this. So dy dx is going to equal to, by now you should be really good at differentiation if you watch my first video. So this is going to be 2x plus 1. I'm not going to go into how we got it, but it's 2x plus 1. Now what I want to know is what is the gradient, particularly at this point here, where x is 2 and y is 3. Well, the gradient basically only needs an x value, so all I need to do is just take that 2 and substitute it in there. So therefore, dy dx is equal to 2 times 2 plus 1. So that's going to be equal to 5. Now I know that the gradient of the tangent is 5. I can now go and find the equation of the line. Now I have a formula I like using. Some people go straight for their y equals the mx plus c to go and find the c straight away. Actually, you know what? Why not? Let's do that. So I'm going to now replace the y, the m, and the x with the values I know. This is my m, that's my gradient. This is my x value, that's my y value. I'm now going to find c using the information I've got. So this gives me 3 is equal to 5 times 2 plus c. Look at it very carefully. I've replaced the y value with 3, because that's the y value in the coordinates there. I've replaced the x value with 2, because that's the x value of the coordinate there. And I found my gradient to be 5, so I've replaced the m with 5. Okay, let's finish this off then. So 3 take away 10 is equal to c. It's just simple arithmetic now, and it says that c is equal to minus 7. Now that I know that, I can now say that the equation of my tangent at this point P, I probably should have labeled it there as P, is y equals to 5x minus 7. And that is done. Yeah, 5x minus 7. Now, here comes the other problem. I need to find the equation of the normal. So let's go for it then. Now, let's just switch colors a little bit because we're doing something different. Equation of the normal then. Now, as you can remember, as I said before, the equation of the normal, it needs a perpendicular gradient. And to find my new gradient, I take the old gradient, which is the gradient of the tangent. And bearing in mind, sorry, I probably should mention this, the normal will be going through the exact same point. It's going to be perpendicular to that tangent that we've got there. So the equation of the normal then, the gradient of the normal is going to be, take the gradient that I got for the tangent, reciprocate it and change the sign. So when I flip it over, I will get 1/5. When I change the sign, minus 1/5. So now that I've got that, and I know exactly what coordinates it's going through, I can do the exact same thing by using y equal mx plus c to find the equation of the normal. So let's go for it then. So same thing again, substitute 2 for the x value, substitute 3 for the y value, but this time your m is going to be minus 1/5. Okay, so here we go. We're going to now have 3 is equal to minus 1/5 x, which is going to be 2, plus c. This gives us then 3 plus 2/5 is equal to c. Finish this off, then that's going to, well, you can just call that 3 and 2/5, couldn't you? So c is equal to 3 and 2/5 there. Now all we need to do is finish writing the equation of the normal, which is going to be y is equal to minus a fifth x plus, let's change that 3 and 2/5 into an improper fraction, which is going to be 17 over 5. And sometimes in the exams, you know, they might ask you to prove it and it wouldn't look like that. So I'll just rewrite it into a way they might, you know, accept it. And what we will do to do that is we'll just multiply everything by 5, and this will give us 5y is equal to 17 plus, minus x. Let's get rid of that. Let's rub that out. 17 and minus x. All I've done is, I don't like minuses hanging out on the end there, so I've just swapped it in and brought the 17 forward. But this is exactly the same as that. Okay, and that's the equation of the normal. If you left yours like this, you're not going to lose any marks, so it's fine. All right, let's move on to the second question. And this time what I'll do is you can pause the video, have a chance to do it, and then once you've done it, we can go through the answers. Alright, so here begins our second question, and you can, like I said, pause the video. You've already written the questions down, so you can pause the video and then have a go. I'm just going to work straight through it now. So again, find the gradient first. So dy by dx is equal to 2x plus 7. And I need to know exactly what the gradient is at this point on that curve. So I'm going to substitute the x value of minus 2 in there, thereby telling me that my dy dx is equal to 2 times minus 2. Probably, there we go. 2 times minus 2 plus 7. So this is going to give me minus 4 plus 7, which gives me 3. So now that I know my gradient is 3, I can now go and find the equation of the line y equals to mx plus c. Again, this is my x value, that's my y value, this is my m. Just going to substitute them in there. That becomes 3 is equal to 3 times minus 2 plus c. So 3 plus 6 is equal to c. I keep missing a step here. I did it before and I didn't sort of tell you why, but when we multiply 3 times 2, we get minus 6. We bring that minus 6 over, it becomes a plus 6. Okay, so in case you're lost as to where that came from, that's where it came from. So c is equal to 9. So it means that the tangent cuts the y-axis at 9, and I can therefore now write my tangent. So equation of my tangent. So equation of tangent is going to be y is equal to 3x plus 9. All right, lovely. Now, and now for the equation of the normal. And for that one then, we will now go through, I'll just keep that nice and separate, an equation of my normal. But first I'll need my perpendicular gradient, so I'll need my perpendicular gradient. And what I do is I take the normal gradient, or the tangent, sorry, the gradient of the tangent, reciprocate it and change the sign. So that gives me minus a third there. The normal goes through that same point. So for my y equals to mx plus c, all I need to do is substitute those values in, and we're going to get 3 is equal to minus a third x, which is minus 2, plus some value c, and then that will now give us 3 minus 2/3 plus c. Just to show you where I got that from again, 1/3 times 2 is 2/3, because the 2 will multiply by the 1 on top. It's a positive 2/3, but when it goes over, it becomes a minus there. And so I should probably change this to equal rather than what I've got there. Let's see if we can make that a little bit better. I'll just scribble that out and put equal c. Okay, now if I take 2/3 away from 3, I will get 2 1/3 left. You can have it as an improper fraction if you want, 7/3. Okay, and so now the equation of my normal is y is equal to minus 1/3 x plus 7/3. And again, this is good just the way it is, but if you want to, you can just multiply out by 3 and then get 3y is equal to 7 minus x. Okay, if you want to, but it doesn't really matter. Okay, I'd like to stop here now because I think you got the general idea. You've got a couple other questions there to do. What I will do is I will write the questions on the other side, on another slide, and the answers for them so that you can check them out yourself. Okay, so hopefully you've worked them out. So this one, your tangent is going to be y is equal to 31x minus 118, and your normal is going to be y is equal to minus 1/31x plus 190/31. If you want, you can multiply throughout by 31. All right. I shall leave you to do this one on your own. I hope the video was useful to you. I'm stopping now because it's quite long. And, you know, have a go at it and then have a go at some of the others that you will have to work out for yourself. Look out for my third video on differentiation.